Hi, I'm Ragav.
And I'm Simran.
And we are students of CHM 2922, and we are discussing our findings in Exercise 5, analysing Fourier transform infrared spectroscopy and Raman spectroscopy to identify contaminants present in analgesics.
Absorption spectroscopy measures how well a sample can absorb light at different wavelengths. A monochromatic light beam is usually passed through a sample, and the amount of light absorbed is measured. In Fourier transform infrared spectroscopy, instead of shining a monochromatic light, a beam containing many frequencies is fired at the sample. The asymmetrical stretching that happens in the molecule is detected, and the amount of light absorbed is measured and done again with a different set of frequencies. The high spectral resolution data is then collected over a wide range by a computer, which gives the infrared spectrum. Raman spectroscopy is another spectroscopy used to identify what compound is present in the laser beam is passed through a sample and the scattered light is detected. The majority of the scattered light is of the same frequency as the excitation source, which is known as Rayleigh scattering. A very small amount of the scattered light is shifted in energy from the laser frequency due to interactions between the incident electromagnetic waves and the vibrational energy levels of the molecules in the sample. Plotting the intensity of this shifted light versus frequency results in a Raman spectrum of the sample.
If a bond is strongly polarized, a small change in its length, such as that occurs during vibration, will only have a small additional effect on polarization. Vibrations involving polar bonds such as CO, NO, OH are therefore comparatively weak Raman scatterers but strong on the IR spectrum. Such polarized bonds, however, carry their charges during the vibrational motion, which results in a stronger, larger net dipole moment change and produce stronger IR absorption band as mentioned before. Conversely, relatively neutral bonds such as carbon to carbon or carbon to hydrogen or carbon to carbon double bonds suffer large changes in polarizability during a vibration, though this is less easy to visualize. But the dipole moment is not similarly affected, and vibrations that predominantly involve this type of bond are strong Raman scatterers but weak in the IR. You will notice that we do not specify each peak for the Raman as we do for the IR, and it is for this exact reason, as the Raman does not show very well the polar bonds, which a lot of our analgesics have, and it will only show the carbon to carbon bonds, so we only show how much of it matches. We analysed 3 unknown analgesics using IR and Raman spectroscopy and compared it to known analgesics and identified the contaminants and adulterants.
Unknown 1. By analyzing the IR spectra of this unknown, we were able to identify various functional groups which corresponded to the peaks from the characteristic IR spectra. We were able to deduce from the IR that the unknown compound contained paracetamol. This conclusion arises from identifying that the peak at 3323 and 1653 correspond to the NH bond and the COO bond, amide bonds. By using the same method of identification, it was determined that acetyl salicylate was also present in the unknown compound. The peak at 1684 corresponds to an ester bond, which is also present on the characteristic IR spectra of acetyl salicylate. Finally, a third analgesic was identified to be in unknown 3, aspirin. There is a peak at 1752, which matches with the COO carboxylic acid peak. The Raman shows a fairly exact comparison with paracetamol, but not as strong with the other spectrums. As you can see, many of the peaks are the same for the unknown one and paracetamol, such as 858, 1238, 1326, and many others, but not so much for aspirin and acetyl salicylate.
Unknown 2. In a similar fashion to comparing compound 1 to the IR spectra of known compounds, we were able to identify 2 analgesics inside unknown 2. The peak at 3132 matches with the OH peak for methyl salicylate. Also, the peak at 2949 corresponds to a CH alkane stretch. We also identified that paracetamol was present in this unknown compound. The peak at 3321 matches with the characteristic NH stretch on the paracetamol, as well as a peak at 1653, which matches with the COO stretch. As you can see from the Raman, there is a strong correlation between the unknown compound and paracetamol, as they have virtually exactly the same, from peaks at 858, 1169, 1326, and 650. But this is not as similar for the methyl salicylate.
This unknown 3. This compound contains two chemicals which we have identified. The peak at 2593 corresponds to the carboxylic acid OH stretch, which comes from the salicylic acid and is confirmed by the IR spectra of salicylic acid. The peak at 3226 on the unknown spectra corresponds to the hydroxylic OH group, which indicates the presence of salicylic acid, as it contains both a carboxylic acid and a hydroxylic group. We believe that this unknown compound also contains aspirin, as the peaks at 2593 and 1607 match the characteristic IR spectra of aspirin, and these peaks are due to the COH carboxylic acid and the C double bond C aromatic ring. The Raman for the salicylic acid and unknowns are basically identical. Hence, we can say for certain that salicylic acid is present in this unknown. However, we cannot say the same about aspirin, as these are quite different. Errors could have come from not clearing the cubicles properly, resulting in extra contaminants, therefore extra peaks and interference with the data. The chemicals left behind could also react with the new chemicals, therefore creating new peaks which do not represent the data accurately.
So, despite us determining, saying that there are these analgesics inside these drugs, we could not say with 100% certainty they were definitely inside, as we do not have enough data to assume this. In order to assume that if the data was for 100%, the analgesic was 100% in the drug, we would have to conduct more tests. So, just a recap of our results. In unknown 1, we had aspirin, acetyl salicylate, and paracetamol.
In unknown 2, we had methyl salicylate and paracetamol.
In unknown 3, we had salicylic acid and aspirin. Thank you so much for watching and listening to us.